Hello everyone, welcome back. This is hopefully the only video for Chapter 3 where we'll just be talking about the built-in objects from Oracle for Java, and we'll spend a lot of time talking about the string class. The first thing I want to do is talk about what it means when we declare something to be of a reference type or an object type. Uh, Up to now, when we've been talking about declaring variables, we may have said I have an int I, and what happens there is that we have basically named a bit of memory called I, and when we have a statement such as I is equal to, say, 5, this statement causes 5 to be copied into I. And maybe I can do this. And so the memory for I will now have 5 in it. That is how primitives are stored. The only thing you can do to a primitive is put a value in, like 5, or read a value out if you want to use that 5 somehow. Objects are not stored this way. I can have, maybe I declare a scanner, keyboard, and this does set aside a named bit of memory for the keyboard variable. But I do not hold my scanner in that little named piece of memory in the same way that I hold 5 in I's piece of memory. Instead, when I have a statement that creates a new object, like we talked about for scanner last time, and let me shrink this down some. There is another piece of memory in another bit of the memory of the computer called a heap, and it's in this piece of memory that I create a scanner object. And so here's my scanner over here. The new operator goes to the heap and creates this scanner object, and what the assignment operator does is it takes the address of this scanner object, and that is the value returned by the new operation. And that value, which is effectively a pointer to this scanner object, is what is copied into this named bit of memory for keyboard. So keyboard is, in fact, a pointer. We can't get to it to manipulate it in the same way that other languages can get to pointers to manipulate them, because Java considers that unsafe, and one of Java's reasons for being is to be safe. But this is under the covers what is going on. So think of object references when you declare scanner keyboard, or when we declare a string S. Think of object references as these two-piece things. They have the pointer piece of memory over here, which is a named piece of memory, but over in a different part of memory, they have this object which is sitting there. The fact that this is two pieces means that we can start doing some mixing and matching with the two pieces. So if I declare a string S here, I get a named piece of memory, which is going to be a pointer to a string object. If I then say S is equal to new string Sophie, what's going to happen is that over in the heap, I'm going to have created for me a string object, and this string object is where the actual letters SOPHIE will reside, and this variable over here is a pointer that points to that string object. Okay, well, I can declare another string object, and I can set that other string object. Well, let me see. It will have a piece of memory associated with T here. And I can set this string object to point to S. S is pointing over here to the string Sophie, and what's copied over in this assignment operator is the pointer. So after this assignment operator is executed, the memory associated with the T variable is going to point to exactly the same place as the memory, as the object associated with the S variable. This is called an alias. S and T are pointing to the same object. And I can also do some other things since I have this two-headed kind of thing that I'm dealing with here. I could have another statement that said S is equal to Sally. Now, you'll notice that up here I said new string Sophie. Here I just gave it the literal string Sally. Strings are objects. They are not primitive data types. We can look up the Java code for strings in source.zip, which was downloaded with your SDK if you're curious. But the compiler understands strings. It understands string literals. So the compiler, when it sees S is equal to Sally, is in fact going to create a string object over here, and it is going to put the letters SALLY in there, and this assignment operator is going to change this pointer, so this pointer will no longer, well, that's not what I want. This pointer will no longer point to the Sophie object, but will instead now point to the Sally object. Now, the Sophie object hasn't gone anywhere. It's still there because T is pointing to it, but S is now pointing to a different place. This memory associated with S is still at the same location, but what's in there has changed. And if I start executing methods on S, like to find out its length or to do something like that, I'm going to be operating on a different object. So that's what this two two piece thing of reference types does for us. My variable S is a pointer, and it points to entities that are objects stored somewhere else. We say they're stored in the heap. And so just get used to visualizing um, reference objects in that way. By the way, this situation down here, where where the compiler is intervening for me and creating objects under the covers, is done for strings and what I call the wrapper classes, which we'll get to, which are in the book for your reading. And the compiler knows about them. The compiler will assist in creating them when necessary and so forth. But there's no way that you and I can get to those facilities. Okay, now that we've talked about how objects are stored, let's look at these string objects in a little more detail. And the first thing I want to say is, well, there's a list of a partial list, a very few of the methods available on the string objects in your book. Um, if you want to look up, if you want to Google Oracle Java API string, it will take you to the API online documentation, and you will see a bunch of methods in there that are actually available. One thing I want to talk about is that strings are immutable. And so going back to my little ugly chart here, I said that when we reassign the S variable to point to the Sally string instead of the Sophie string, strings being immutable means that once this string object is created, and this is the Sophie one here, right there in the middle on the right, once that string object is created, it cannot be changed. Okay, no way to change it at all in any way, shape, or form. But you look at this list of methods available on the string object, and you say, well, I see this to uppercase. Certainly that's going to change the string to uppercase. So I want you to, on line 10 here, copy this code out. On line 10, you see that we create a string S, we assign the string the value lowercase Sophie, and we print it out. That's going to print Sophie, fine, in lowercase. And then we execute S to uppercase. And now I want you to pause the video and put in a print line for S and look at the output and see if that's what you expect. So I'll wait a couple of minutes and then we'll resume. Okay, let's put in our system out print line. And let's save it and let's run this. Run as Java application. And Sophie in lowercase was printed out down here in the console, which is what we expected. That's coming from line 6. That's our or excuse me, line 7. That's our first print line. But then the second print line on line 10, which was after the 2 uppercase, is still Sophie in lowercase. So did the print line not do anything? Or did the uppercase, 2 uppercase, not do anything? Well, it did, but it didn't do anything to that Sophie object. Since strings can't be changed, what 2 uppercase does is create a new string. And what happened on line 9 here, the s.2 uppercase, we created a new string object. It had uppercase Sophie in it. We did not do anything with that new string object, and so Java threw it away and proceeded, and S was still pointing to the lowercase Sophie, and that's what we printed out. If I want to fix this, I have to save a pointer or a reference to that new string object, the uppercase version. So maybe I want to do string T, and I'll initialize it as being S to uppercase, and I will add a print line for T. And now if I run this again, hopefully when it runs again, I get 2 lowercase Sophies and 1 all uppercase Sophies. Line 11 printing out this uppercase Sophie down here. So moral of the story, when you do something that looks like it's changing a string, 2 uppercase, 2 lowercase, replace, or whatever, you are not changing the string. You need to save the new string that's created with your changes, because that existing string object, the object, cannot be changed. It is immutable in Java. But remembering how the assignment operator works, what I can do is say S is equal to S dot, well, I said lowercase. Let me try again. To uppercase, and it's case, not cast. It's still case, not cast. There we go. And remember how the assignment operator works. I evaluate what's to the right of that assignment operator, S.2 uppercase. That creates a new object and returns a pointer or a reference to it. I then take that reference as the second part of the assignment operation and put that reference in the memory associated with S. So S is no longer pointing to the lowercase Sophie. S is now pointing to the uppercase Sophie. So if I now do a print line on S and run this, I get 2 lowercase Sophies, one from line 6 and one from line 10, and I get 2 uppercase Sophies, one from line 11 with the T variable, and one from line 14 with the S variable. There is something else I'll just point out. I can pass an object reference to a print line. 2 lowercase will take S, which at this point is an uppercase Sophie, and it will pass that reference to the print line method. And let's see what this will print. Now I get a lowercase Sophie from line 15, s.to lowercase. Whereas just before we saw on line 14 that s was now an uppercase Sophie. Now that new object generated on line 15 with the s.to lowercase method call is passed to the print line, and after that is thrown away. It's no longer accessible because I didn't store it anywhere, such as like I did on line 13 or line 9, but I did print it out. So that is a possibility if you don't need to reference things in the future. There's only one other thing I want to mention, and that is about the random class, random number generator. And you'll see it does not compile because I need to put in the import random from java.util package. And up here we saw that Eclipse imported java.util.random for me. The most commonly used method that we use, at least on random, is the next int. And I'll put 10 here. What I want to point out is that this 10 is exclusive. It does not include 10 in the things that random will put out. It will give us numbers between 0 and 9, excluding the 10. Just something for you to keep in mind when you're doing problems. A very, very common error is that people think that 10 might be coming back from that random number generator. It will not. The highest number will be one less than this parameter value here that's on line 19. That's one thing I wanted to point out about random. Another thing about strings, before I forget, everything in Java, nearly everything in Java, is zero origin. So here, the length of Sophie is 1, 2, 3, 4, 5, 6. So Sophie.length will return 6. But the characters of Sophie, if we're using the char@ method, the characters are numbered from 0. So char@ 0 is the S. Char@ 1 is the O. Char@ 5 is the E, that final E. So the length is 6. The characters are 0 origin, numbered 0 through 5 in this case, 1 minus the length generally. Okay, so I think that'll get you started for Chapter 3 until we can meet again. And I hope you enjoy playing with Java.